Hi everyone. Today we're going to be completing our notes on building the unit circle. I want to start off with a couple definitions. The first is the unit circle. What is the unit circle? So the unit circle, like all circles, is defined by the radius and the center. So the unit circle is centered at the origin, 0, 0. And the radius of the unit circle, well, it's the unit circle. So unit meaning 1, that tells us the radius. The radius is 1. So it's the radius 1 centered at 0, 0. So consider the circle which has radius 1, the unit circle. We can use this circle to find all the trig ratios of angles that have a reference angle of 30, 45, or 60 degrees. Here's how. So the other definition that I want to start off with is reference angle. What is a reference angle? A reference angle is the positive acute angle formed by the terminal ray and the x-axis. Okay, so a reference angle is the positive acute angle formed by the terminal ray and the x-axis. So there's 4 points to this definition. It's positive. All reference angles will always be positive, no negative angles. It's acute, so it's got to be between 0 and 90. So if you have a reference angle of 135, you know that something might have gone wrong. It's formed by the terminal ray, so where the angle ends up, and then also the x-axis. This is one of the most common errors that I see students make. They'll form their reference angle with the y-axis. Be very careful, it's always formed with the x-axis by definition. Okay, so let's start off with a reference angle of 30 degrees. So I want to just recall our special right triangles from geometry. I'm going to go ahead and draw a special right triangle here, a 30, 60, 90 triangle. Okay? So what you might have remembered from geometry is that the ratios of side lengths for 30, 60, 90 triangles is that the side length across from 30, if we call that side length S, then the side length across from 60 is going to be S root 3, and then the hypotenuse will always be 2S. This is always going to be the ratio of sides for a 30, 60, 90 triangle. Okay? So if we're looking at the unit circle, our hypotenuse will always be 1. Okay? So if 1 is equal to our hypotenuse, or 1 is equal to our 2s, I can use that to solve for s. Dividing both sides by 2, I get that s is equal to 1/2. So that tells me that my side length s, the side length across from 30 degrees, is going to be 1/2. Well, and if that side length is 1/2, that tells me that the side length across from 60 is going to be a multiple or a factor of root 3 times that. So I have root 3 times 1/2, or root 3 divided by 2, root 3 halves. Okay? So if I wanted to start building the unit circle here, suppose then I have a reference angle of 30 degrees. Okay? So we're looking at this angle in quadrant 1. So this is the angle, the positive acute angle formed from the terminal ray and the x-axis. So we have this angle right here, 30 degrees. If we were to hit that point on the unit circle, well, and then drop a perpendicular, we know this forms a 90-degree angle. And we also know that this distance from the origin to the edge of the circle is 1. This is our unit circle. Therefore, that's a radius. So now we have a special right triangle with a reference angle of 30, and the hypotenuse is 1. So that tells me that this vertical side length across from 30 must be 1/2. And our horizontal component is going to be across from 60 degrees. This is a 30, 60, 90 triangle, or root 3 over 2. In radians, this angle, 30 degrees, is pi/6. So then the coordinates for this point on this endpoint on the unit circle is going to be the horizontal component, root 3 over 2, comma, the vertical component, 1/2. So remember, to get to the point, you got to go right, and then you got to go up to get to that point on the unit circle. So we go right root 3 over 2 units, and then we go up 1/2 unit. Okay? Suppose then we have 150 degrees. So if I were to have 150 degrees, that would be this distance all the way around in quadrant 2. So if this is 150 degrees, or 5 pi/6 in radians, then my reference angle, I know that the negative x-axis is 180 degrees. So my reference angle is going to be that difference in those angles. The difference between 180 and 150 degrees is 30 degrees. I know that this hypotenuse here is 1, drop a perpendicular, and again, we have that 30, 60, 90 triangle. So our reference angle here is 30 again. So we have that vertical component is positive 1/2, but our horizontal component, because we're in quadrant 2, this endpoint is in quadrant 2, our x component is going to be negative. So we have negative root 3 over 2. The reason why is because to get from the origin to this point, we would plot this by going left root 3 over 2 units and up 1/2 units. So we have a negative x component. So the coordinates for this point on the unit circle is negative root 3 over 2, positive 1/2 in quadrant 2. In quadrant 3, 210 degrees. So again, we start at the positive x-axis and we measure around 210 degrees. The reference angle, that positive acute angle formed from the terminal ray and the x-axis, is again 30 degrees. That's the difference between 210 and 180. So we have a 30, 60, 90 triangle. If we drop that perpendicular, our vertical component is going to be negative 1/2 because we're going down. So we have a negative vertical component or a negative y value. So our coordinates for a reference angle of 30 degrees in quadrant 3, or 7 pi 6, would be negative root 3 over 2, negative 1/2. Both x and y coordinates are negative in quadrant 3. And finally, and let's go ahead and label that hypotenuse. Finally, in quadrant 4, 330 degrees, or 11 pi 6 radians, we have a reference angle of 30 degrees because the difference between 330 and our positive x-axis, 360 degrees, is 30. Hypotenuse is 1. Drop a perpendicular from that endpoint on the unit circle. The y component, that vertical component, is going to be negative 1/2 because we're going right and then down. That's our negative vertical component. So the coordinates on the end of the unit circle is root 3 over 2, negative 1/2. Okay? All right, let's switch it up. Let's now say a reference angle of 60 degrees. So again, we have the same ratios of side lengths. I'm not going to rewrite it, but we have s, s root 3, and 2s for the side lengths across from 30, 60, and 90 respectively. But on the unit circle, our hypotenuse is 1. Therefore, the side length across from 30 is again 1/2, and across from 60 is root 3 over 2. So if I'm going to find these endpoints on the unit circle, we'll start with quadrant 1. So 60 degrees. The reference angle in quadrant 1 is just simply the angle, 60 degrees, because we're already defining it from the positive x-axis. So pi thirds is the radian equivalent. We have a 30, 60, 90 triangle here if we drop a perpendicular from the endpoint. So across from 30, we have our 1/2, and across from 60, we have our root 3 over 2. The coordinates for this point on the unit circle is 1/2 root 3 over 2, both positive in quadrant 1. In quadrant 2, again, that hypotenuse of 1, reference angle is 60 degrees. So 120 degrees. The difference between that and 180 is 60 degrees. Drop a perpendicular from the endpoint. We have a 30, 60, 90 triangle where our vertical component is root 3 over 2 and our horizontal component is going to be negative 1/2 because we're going to the left and up. So our coordinates on the endpoint on the unit circle is negative 1/2, positive root 3 over 2. Let's try quadrant 3, 240 degrees or 4 pi thirds. Again, the reference angle is 60 degrees. And so we have drop a perpendicular from that endpoint on the unit circle. We have a vertical component of negative root 3 over 2 and a horizontal component of negative 1/2. So we have the coordinates for the endpoint on the unit circle, negative 1/2, negative root 3 over 2. They are both negative in quadrant 3. And finally, in quadrant 4, if we have 300 degrees or 5 pi thirds in radians, we have a reference angle of 60 degrees. Again, a 30, 60, 90 triangle where the vertical component is negative root 3 over 2. And the horizontal component is positive 1/2. So x is positive, y is negative in quadrant 4. All right, we got one more, and that's going to be our 45, 45, 90 triangle. So again, if you remember back in geometry, these are, another name for these are isosceles right triangles because they have two congruent angles, so two congruent sides, and then they're right triangles. They have a 90-degree angle. So isosceles right triangles. So again, if we were to say that those congruent sides are side length s, then the hypotenuse in this case would be s root 2. Now on the unit circle, if our hypotenuse is equal to 1, that tells us that 1 is equal to our s root 2, right? And we could solve for s by dividing both sides by root 2. So then s must be equal to 1 over root 2. Well, we can't have this as an answer. We can't have a radical in the denominator. So to rationalize this denominator, I'm going to multiply by a clever form of 1. I'm going to multiply by root 2 over root 2. And this isn't going to change the value, but it's going to change how it looks, right? So in the numerator, we have 1 times root 2. We get root 2. In the denominator, root 2 times root 2 is simply just 2. So then our side length s is going to measure root 2 over 2. So again, on the unit circle, if our hypotenuse is 1, then our side lengths are root 2 over 2. Okay? So let's see what this looks like practically on the unit circle. So we'll start with quadrant 1, 45 degrees or pi-4 radians. Again, our angle in quadrant 1 is also our reference angle. Drop a perpendicular from that endpoint on the unit circle, and we have a 45, 45, 90 triangle. The hypotenuse is a radius, so that's equal to 1. So therefore, our horizontal and vertical components are both positive root 2 over 2. So the coordinates for the endpoint on the unit circle are root 2 over 2. In quadrant 2 at 135 degrees or 3 pi-4 radians, we have a reference angle again of 45 degrees. The reason why is because the difference between 180 degrees, the negative x-axis, and 135 degrees is 45 degrees. That's that positive acute angle formed from the terminal ray and the x-axis. Just a reminder for reference angle. So then our horizontal component is going to be negative root 2 over 2. That's because we're moving to the left. And then we're also moving up, so that's going to be positive root 2 over 2 for our vertical component. So the coordinates of this endpoint on the unit circle are negative root 2 over 2, positive root 2 over 2. In quadrant 3, 225 5 pi-4 radians, we have, again, hypotenuse of 1. A reference angle difference between 225 and 180 is 45. So we have a 45, 45, 90 triangle if we drop a perpendicular from that endpoint on the unit circle. We have our horizontal component. Our vertical component is also negative root 2 over 2. So then our coordinates on the endpoint of the unit circle is negative root 2 over 2, negative root 2 over 2. And finally, in quadrant 4, 315 degrees or 7 pi-4, we have this something similar, right? So the difference between 315 and 360, our positive x-axis is 45 degrees. Drop a perpendicular from that endpoint on the unit circle. We have our vertical component is negative root 2 over 2, and our horizontal component is positive root 2 over 2. Okay, so we've covered a lot. Let's put it all together. All right, so here's the unit circle, and now we've drawn in all these triangles and all these angles. We'll start in quadrant 1, and then I'll show you a pattern. So quadrant 1, we'll start with the positive x-axis, 0 degrees or 0 radians. This is the unit circle. So this point on the end of the unit circle, well, it's just a radius. So we have the coordinates 1, 0. We're going to the right 1 unit, and we're not going up or down at all. 30 degrees or pi-6. Remember, that's that long side is our horizontal component, so that's our root 3 over 2. The short side is our vertical component, that's our 1 over 2, or 1/2. 45, that's our isosceles right triangle, that's going to be our root 2 over 2, root 2 over 2. We just did that one. 60, it's going to be just like 30, but then it's going to be flipped. So the short side is the horizontal component, 1/2, and the long side is root 3 over 2. That's our vertical component. And our next quadrantal, 90 or pi-halves radians, is again on the unit circle. So it's got to have a radius of 1, but it's going straight up. So we have the coordinates 0, 1. Okay. So really all you need to know is quadrant 1 and then recognize the patterns in the remaining quadrants. I know that quadrant 2 is exactly quadrant 1, but reflected over the y-axis. So reflection over the y-axis means we're going to take all of our x values and make them negative. So 180 reflected is going to be negative 1, 0 from 0 degrees, right? Likewise, 150 degrees, that has a reference angle of 30, so I know that my x values for 30 is going to be just negative, but otherwise the quantities there are going to be the same. 135 has a reference angle of 45 degrees, so that's going to be negative root 2 over 2, positive root 2 over 2. And then 120 is going to be the reference angle of 60, but in quadrant 2, so a negative x, negative 1/2, and positive root 3 over 2. Another way you can visualize this is try to see which side length of the triangle is going to be longer and which side is going to be shorter, and that's going to tell you between your 1/2 and root 3 over 2. Next, in quadrant 3, we know that quadrant 3 is exactly quadrant 2, but then reflected over the x-axis. So that means that all of our y values are going to be negative. So then our 210, that's our reference angle of 30. Well, that tells me that it's going to be this exact coordinate pair right here, but then with a negative y. So we have negative root 3 over 2, negative 1/2. 225, or 5 pi fourths, has a reference angle of 45, or pi fourths. So we have that isosceles right triangle, both negative root 2 over 2. And finally, 240 is our reference angle of 60, so that's going to be negative 1/2 and negative root 3 over 2. Our next quadrantal, 270, again, that's on the unit circle. We have 0, negative 1. 300 is our reference angle of 60. So by the way, quadrant 4 is going to be exactly quadrant 3, but then reflected back over the y-axis. So then all of our x coordinates are going to be positive again. You can also visualize this as the reflection over the x-axis from quadrant 1. So then the coordinates for 300 degrees, or 5 pi thirds, is going to be positive 1/2, negative root 3 over 2. For 315, or 7 pi fourths, is going to be positive root 2 over 2, negative root 2 over 2. And our last one, 330, or 11 pi sixths, is going to be positive root 3 over 2, negative 1/2. Okay. One last thing I want to talk about, if you're confused and wondering why we have these quantities here in this order, remember the distances. Like, consider the x values here. The greatest is always going to be 1. This next greatest is going to be root 3 over 2, and then root 2 over 2, and then 1 over 2. We can remember this as we know that the greatest we said was 1, and then root 3 over 2. We said then root 2 over 2, and then 1/2. Well, we can write this as descending roots over 2. So if we were to say root 4 over 2, and then root 3 over 2, and then root 2 over 2, and then root 1 over 2, you might notice some of these simplify, some don't. Like root 4 over 2, the square root of 4 is 2, over 2 is 1. And then the square root of 1, we're over here at 1/2, the square root of 1 is just 1, over 2 is 1/2. So you can see where these numbers come from. We have root 4 over 2, root 3 over 2, root 2 over 2, root 1 over 2. So sometimes I find this type of conceptualization helpful for determining which quantities are going to be greater and which ones are going to be lesser. So when we're looking at these angles, try to figure which side of the triangle is going to be longer and which side is going to be shorter. Okay, the same is true for our y values. So like for 60 degrees, we have a taller y value than we do a wider x value, right? So that y value is going to be greater than our x value. So something to consider as you're building the unit circle. This does look intimidating, but we're going to get so much practice on this. So we'll see you tomorrow in class. Have a great day, everybody. Goodbye.